Hello, students and parents. Today we're going through our Chapter 12 review page. As I mentioned in class, this is to cover everything we learned before break, prepping us for our quiz, which will be next class. So I do hope that this is going to be a helpful video, just going through everything we've done. I will bring out the chickens, so let's go ahead and start with that. Here we go. All right, Teddy, Beatrice, myself, we're all going to go get the chickens. Here they are. Let's run and see them chase after me. They're like, we ran all this way for what? So I gave them some scratch, just a bunch of seeds. I'm gonna try to grab one of the little ones. They're very tricky to grab. I got it, BB. Okay, we're back from the chickens, so go ahead and get ready to do some math. I will say stay on this towards the end, and I'll share a video of a cow that I saw at my past weekend's adventure, which I shared in class, going to Mission Peak and just seeing all these cows everywhere. So I'll have that, as well as I said it was very windy, so I'll show you how windy it was. But this one lists the sample space, so we want to know one of each and not repeating is the easiest way. So we have P, we have an A, we have an R, we already had A, so we don't do that one again, and then we have D, and we have E. So that is our sample space from that word parade. Mississippi, you see a lot of repeating words there. So we have an M, we have an I, S, we already did the S, we already did the I, we already did the S, 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 and P. So M, I, S, and P will be our sample space. All right, next one, use the spinner to find the probability of each result. Give the answers in fractional form. That means we want to write it in the A over B format, like that, as a fraction. All right, first things first, we want to know the probability of the spinner landing on an even number. So we count the even numbers. We have 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. 5 out of, how many are there? There's 10 numbers. 5 out of 10. We can divide both by 5, and we should get 1/2. So you have about a 50% chance of landing on an even number. It's pretty good, right? Or 1 out of 2 chance of getting there. All right, a number greater than 5. So we can't choose 5, but let's count. So 1, 2, 3, 4, 5. Also, 5 out of 10, which equals 1/2, or 1 over 2. All right, even or, this was a typo that I had us correct in class. So landing on an even number or 5. So we know an even number would be 5 out of 10. So that's 1, 2, 3, 4, 5. Now let's add one more, 6. 6 out of 10. And if we reduce that, we would have 3 over 5. All right, not 2 or 6. So we want to take 2 and 6 out, and then count everything else there. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 out of 10, and then we need to reduce that. If we divide both sides by 2, that would get us 4 over 5. Alrighty, so that gets us through that one. I think with these, the main thing is just read the directions so we know what we're supposed to be doing, and then just double check your work. So these look like they could be very simple because you're like, just 10 numbers, but double check your work. So if it's not 2 or 6, then I count 1, 2, 3, 4, 5, 6, 7, 8. Do I have 8? Yes. Is 8 divided by 2, 4? Yep. 4 times 2 is 8. Yes. 5 times 2 is 10. Because it's very sad if you get it wrong just because of a more simpler, arithmetic error. But if I see your work, it's much easier to get some partial credit as you're going. All right, next one says, using a 6-sided number cube, give your answers in the fractional form. So we're using the same form. Listing the sample space. So if you think of, you have a number cube and you have a die. sample space is one of each of what you have, just as we did in here, and you can't repeat. So I know one side, it says 6-sided, so there's a 1, there's a 2, 3, 4, 5, and 6. All right, that is for that. And how about the probability of rolling a 5? Well, if I know there are 6 sides and there's only one 5, the probability would be 1/6. All right, as we continue on down, it says use the following table to give the answers to the following questions. Give your answers in the fractional form. So we don't need to do percentages. We have this right here. And first thing we want to do is go ahead and add up the different numbers of cards so we know what it's going to be out of. So 3 and 2 is 5. This would be 9. This would be 14. This would be 11. This would be 25. All right, so it's going to be out of 25. So when it says the probability of 8 points, we look at points here. So 8 is what it's asking for, and there's 5 cards that have the number 8 on it. So we would do 5 out of 25. Can we leave it like that? No, because we can reduce that if we divide both sides by 5. The top and the bottom, then we would get 1/5. So the probability of getting 8 points is 1/5. All right. How about the probability of 9 points? So we look at 9, we see it's got a 3. 3/25. Can this be reduced? No, it cannot. So we would keep it like that. And we're already on the back. We are just flying through this. How fun is that? All right, the back, using the table, find the experimental probability. Give your answer in the fractional form. So this is where we start picking up on the words that are being used, because we're going to need to answer it down here, theoretical versus experimental. But the experimental probability is they actually ran this experiment, and the frequency of how many times they got 1 was 5. How many times they got 2 was 3 times. 3, 4 times, 4, 8 times, 5, they got it 2 times, 6, 4 times, 7, 3 times, 8, 3 times. So experimental means you're actually doing the experiment, versus theoretical is in theory what it should be. All right, so the probability of 4, well, before we do that, we don't know what it's out of, so we need to add these up. So we have 8, 12, that gets me a nice 20. And then we have 6 and 6, which equals 12. Add these together, and we get 32. Sweet. This is a very fun way of doing it without having to do like a very long this plus this plus this. So pick that up if you like that, or if that makes sense to you. I think it's a very fun and fast way to do it. So we have it out of 32. So now we can look at 4 and we see it's 8 out of 32. Well, I know that that can get smaller. I know I can divide both sides by 8. So that gets me 1/4. So the probability of getting the 4 is 1/4. All right, number 12, a 1 or a 3. So 1 has 5 plus 3 is 9. 3 has 4, sorry. But 4 plus 5 equals 9, 1 or 3. I was thinking faster than my hand was writing. So that gets me 9 out of 32. Can that get any smaller? Can 3 go into this? Not evenly, so no, we're just going to leave that as 9/32. What is the theoretical probability of each card? So in theory, if I have 8 cards, I should be able to pull them 1 out of 8 times. I should get each of them. That's the theoretical. But we saw that that was actually not the case in the experimental, like once we did the experiment. Just like when in class we had the spinner, is we could figure out based on the colors of that twister board spinner that we should get it, you know, an even amount of time. In theory, that's what we should get. But we found that that was actually not the case. The experimental probability showed us something different. All right, and lastly here, it says, how many of each card would you expect to pick in 32 draws? Well, we can do 32 times the experimental, or no, the theoretical that we just did, because it's saying how many of each card would you expect to pick in 32 draws. We know that each draw, the theoretical for each card is 1/8, so we just multiply it by 32. So we multiply across this way, so we have 32 divided by 8. If you reduce that, that cancels out, and we'd have 4/1, or just 4. So we would expect that we would get each card 4 times. The last one here, how do theoretical and experimental probabilities compare? Well, theoretical is, in theory, what should happen. In experimental is what actually happens. And we'll say once you do the experiment. So how I remember it is, I don't know, there was this really kind of brainiac, smart kid growing up in elementary school, and he would always say, in theory, da 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 da. And so I just think of that kind of nerdy, fun character, you know, not even that student, but just like those characters who are always like, in theory, this is what should happen. And that's exactly how I can remember it. In theory, you know, we should be able to pull the cards every 1 out of 8 times. We should get that card. But experimental, we're doing the experiment, so we're actually partaking in it, and that's what we did with that twister board, and why I thought it was so cool, even though I don't think many of you thought it was that exciting. But we actually did the experiment. Same with the coin. We flipped the penny. You each got a penny that I gave you. We are doing the experiment to see what actually happens when we do that. So as long as you can remember that, think of a, you know, let's see, a nice little guy with some nice glasses and maybe some buck teeth, some ears, and then like this. In theory, I just imagine him saying that. Not the best, but I don't know, kind of fun, right? But overall, hopefully this was helpful. Now let's cut to the cows. So this is the cow that I ended up petting. She looked happy until she didn't, so I stopped. But I did think of you guys and how you would have loved petting the cow too. And then remember, it was so windy, stormy, I could barely keep my eyes open. Look at my cross necklace there. But let's end with the cow.